Hey, George, you're a scientist.
I'm a chemist, yes.
Right, you're a scientist. So, I was actually just having a conversation with my friend's wife recently, and she was talking about like we have people like in space, right? We have astronauts with the space station, and we communicate with them, but she recognized correctly, as far as I understand it, that like sound can't travel through space. So like we are getting sound to and from them, but I recall from the great late 80s philosopher James Cameron that in space no one can hear you scream. So how are we getting sound information to and from them and in a way that I could explain to her?
Excellent. Well, darn it, Lyons, I'm a chemist, not a physicist, but with my very limited knowledge and very limited expertise, I will attempt to apply into this. And this is one that, I feel like a lot of people, understand, but there's also a lot of people that I feel like they're in the same boat as your friend's wife, right? Where they're like, hey, I get these two things I know are facts, and both facts make sense independently, but when I put them together, it doesn't really makes sense, So how do we get sound through space? Well, first, let's start at the top. What is sound?
Sound is vibrations through a medium, I think. I think it can be anything, right? A solid, a liquid, a gas. Like the vibrations is what we would call the sound information.
Correct. It is to put it into two words, is a mechanical wave. So it has to.
I like that.
Isn't that a cool word? Yeah. Because there are non-mechanical waves, as we will discuss soon, right? But yes, to your point, right, is that the idea is that the medium, whatever it's in, compresses and relaxes as things move through it. It's just like when you drop a penny into the water and the waves kind of ripple out. It does a very similar thing through any medium. And the compressibility of the medium changes, like the speed at which it travels and all that kind of good stuff, right? And you kind of mentioned it at the top of the hour, so you don't have to play more of the patsy than is necessary. So with the idea of like what is sound, how do you think we get sound through space?
Well, I know we can convert we can convert information from like medium to medium, right? This is a thing I think you and I may have talked about this before. I'm not sure if we talked about it in this particular cafe, but like fiber optics like confuse me a little bit because like I understand that it's a light signal as opposed to like an electrical signal, but I think of light in like the macro sense of like I can see this beam of light, and fiber optic cables don't have to be perfectly straight lines, right? And so it's like there's light
really
information.
Cool how that works too, by the way.
Right? Yeah, like it's like bouncing through the cable, which I think is like glass or something. But it's like just kind of like the friend we're talking about is like I understand that it works, not exactly how it works. So my guess would be we are taking sound information like into a microphone, like the ones we're not talking into right now because we're in person as we always are, and then we are converting it into something else, radio waves, satellite signals, something, and we beam that, and then that's reconverted into like through a speaker.
Yep. And it's all, so basically, yeah, so got it in one, nailed it, right? So basically what we're doing is we're taking sound waves, we're converting those into ones and zeros. We're then converting those ones and zeros into some type of light. We are then shooting that light at a receiver. That receiver then acknowledges that signal, and then it has a thing that vibrates a medium, and it then, vibrates it back out. So it's encoded and then decoded. So just so that's kind of the answer to the question. But one of the interesting things is that, so if light isn't a mechanical wave, right, then what is it?
Ooh.
Yeah. This is the side quest where I was like, it's fine if you get the main quest. I got some side quest stuff.
So light is electromagnetic, right? So,
which in and of itself, I feel like doesn't get enough attention, because we always say light's electromagnetic radiation, and everybody focuses on the electric part, and nobody focuses on the magnetic part, and that like you can induce an electric field from a magnetic field.
Yeah, everybody always asks how magnetic, but never why magnetic.
Exactly,
Yeah, so I guess I would say like electromagnetic waves as opposed to mechanical waves.
Yes, they are. But interestingly, light falls into a category called a field force. So, and that's why it's able to travel without a medium, is because it's basically like a force that generates a field of interaction as opposed to just kind of like compressing and expanding matter, you know? And there's actually 4 field forces. And so let's say for a minute that you know that light is a field force, but you don't know whether or not it can travel through a vacuum. Like we know this, right? So the thing is that you could actually look at some of the other field forces and say, well, if it is similar in characteristic to these other fundamental field forces, it probably could. So there's 3 additional. So light is one of them, electromagnetic radiation. One of them is the strong nuclear force, which is the thing that holds atoms together, and I hope works in a vacuum, because when you get when you get down that small, it's all vacuum, Morty. So, yeah, because, you know, obviously it can't be transmitted through matter when it is the matter, you know?
What's the old story is like the guy goes to see the doctor and he's like, "Doctor, I'm depressed." And the doctor's like, "Oh, you should go see the famous clown that's in town right now." And he's like, "But doctor, I am that clown." It's like an old, like, it's like, yeah. "But doctor, I am the matter."
Yeah. Yes, exactly. And so the one of the other ones is the weak nuclear force, which is involved in radioactive decay, and I don't understand it a whole lot, so we're going to move on. Literally all I know about the weak, if you said like what are the 4 field forces, I'd say light, strong nuclear force, weak nuclear force, and and I can tell you a lot about light. I can tell you a lot about the strong nuclear force. I can tell you a lot about the 4th one, which I'm going to make a guess. But and I'm like, and the weak nuclear force deals with radioactive decay. No follow-up questions allowed. That's
I will not be taking questions at this time.
Thank you so much. Goodbye. So with that in mind, do you and with the idea that all of these can obviously travel through or you know affect through a vacuum, travel through a vacuum, what is the 4th fundamental field force?
So I have not heard the term field force. At least I don't think I have, but I have heard of the fundamental forces, and I am really hoping that the last one is gravity.
It is gravity.
Gravity.
Right? Woo! Yep. Yeah. It's the so yeah. The fundamental forces are all field forces. And gravity. And actually, as I was saying, like, what's some of the fundamental forces? I'm like, oh, well, the force, it binds us, it penetrates us, it holds the universe together.
Light, dark, and balance.
Light, dark, and whatever's going on with Yoda's lightsaber fight. I don't know what that was. But yeah, gravity is the 4th one, right? And it's one of the ones that we're like, hey, we kind of have this big like catch-all for gravity, but we're like, hey, how is gravity actually transmitted? Is it, you know, transmitted through gravitons and, you know, all that kind of good stuff? But I say that yes, those are the 4 fundamental field forces, and all of them travel through a vacuum, as does light. So that's makes it an ideal thing to travel through all of these different mediums, because, you know, it goes pretty fast. The only thing that would reasonably be a better way to transmit information other than light, or at least a faster way, is through like quantum entanglement. And I think that's wild. And I don't know a lot about it. And actually I saw a great video recently where it was a professor who was teaching quantum mechanics. And he was like, I am going to try to teach you quantum mechanics, and I am going to fail, because nobody really understands quantum mechanics. If you say you understand quantum mechanics, you're lying. I don't understand quantum mechanics, and by the end of this class, you will understand it as little as I do. And just like moved on. But the idea with quantum entanglement is that like if 2 particles are entangled at the quantum level, an impact on one impacts the other. So you could then say like, oh, you know, this one is registering 1s and 0s as up and down spin, and then as the other one it instantaneously registers its up and down spin, you could decode that information, which is now what I am convinced is the way the communicators work in Star Trek.
I thought you were going to say the Ansible from Ender's Game.
Yes.
Yeah, because that is it. I don't remember it ever being a particular plot relevance in Star Trek, but it is absolutely integral to the plot in Ender's Game, because everyone assumes like, well, we can't have faster than light communication because things can't go faster than light, but they did have faster than light communication. And that's the titular Ender's Game, is he thinks he's playing a game, but he is commanding real troops that are like a bajillion miles away. Right. And so I do actually, all the things you just said about like, what could you do with information on that? Like, I have heard that kind of thing before from like a tech angle of like, what could you do with computers if they were essentially infinitely fast, right? But the crazy thing that you just made me think of is, if you can use a field force to encode something, and then that field force can be used to communicate through a vacuum, that means that if you had a way to manipulate gravity or the strong or weak nuclear force, that you could use those as communication channels.
Yes, which
just sounds
wild,
insane.
Right? Yeah, well, and actually one of the interesting things about and I forgot to mention this during the strong nuclear force segment, is does the strong nuclear force work in a vacuum? It absolutely does, because here's one of the cool things about the strong nuclear force is it's the thing that holds, like, that makes a proton a proton. It holds all the quarks together to make it a proton, and we've gotten crazy enough that we can actually start to pull those quarks apart, and the strong nuclear force works really hard to keep them stitched together. And the wild thing about it is it gets stronger the further away the particles are, not weaker. So
yeah, do I remember you saying at some point that there's something that, like, if you put enough energy in it to separate it, it just makes more of itself so that it doesn't have to be too far apart?
Yep, it's called encapsulation. And so basically is if you've got, like, I think it's 3 quarks that make up a proton, if you pull one of the quarks far enough away, it will simply make a new quark, so that way it's fine again, and it'll just encapsulate itself. And then the other one will make its other quarks and then encapsulate itself. So it's like, oh, I poured a bunch of energy into this to pull these two things apart so I could look at them. And they said, nah, we like being protons. And they just generate more stuff. So that way, you know, they can become protons. And that's the wild world we live in. I mean, like, even with the Heisenberg uncertainty principle, the idea is that the shorter delta T you have, the greater uncertainty you have with your delta energy, which is why it's like, I've got an absolute vacuum. Unless you look at it fast enough, then there's stuff in there. Because because there's enough, because if delta T is small enough, then delta E becomes large enough that it could generate matter, and matter just kind of blinks in and out of existence occasionally. So I just kind of like the idea that we have become so powerful with all of these different things we can do, but then sometimes physics is like, hey, Nan, there are some rules, and I'm going to expect. So, like, I get that you like to make a vacuum, and you really like that vacuum, and I'm going to let you make a lot of vacuum, but not all of it. There's still rules.
So I love that, you know, my friend's wife had, I think, a relatively, like, reasonable question, right? Just like, oh, yeah. How, you know, how, I know that these two things are true, but I don't have the connective tissue for, like, how they can both be true at the same time, right? Because they seem like they would be antagonistic. It's like, okay, so we translate, we encode, I think is actually the right word. You're correct. We encode this information into a different channel that we can do across the vacuum, and then we decode it, and then we get the job done that we want. And in the path of answering that, we're like, yeah, but what if we could manipulate gravity and use that to communicate? What if we pull atoms apart and use that to encode information? So that is exactly why there are a certain kind of people that like to eavesdrop on these conversations, and a certain kind of people that are just like, what?
Yeah, I don't. Could not possibly care less about any of that. And the last thing I'll say too is the interesting thing, I think, with the difference between Ender's Game and Star Trek is that, like, in theory, with space travel as we know it to exist now, right, is that it's no fun, because you launch a spaceship at nearing the speed of light. It takes 10 years for them to, best case scenario, it takes 10 years for them to travel 100 light years or whatever, right? Or excuse me, it takes them, from their point of view, it takes 10 years. From our point of view, it takes 1,000 years, right? So then everybody they know on the original Earth is dead. They then colonize this new planet, but any communications take 200 years to get there and back. So they basically, you just send off a ship, they effectively all die, and then, you know, like, after a few millennia, they become their own civilization, their own race. So it's no fun. So we have to create magic in order to create fun space stories. And I do think that the reason why the Ansible registers more in one's mind in Ender's Game is because in Star Trek, they have warp and they throw out time dilation. So they basically have near instant movement. So instant communication doesn't seem as weird. But when they really hammer home the time dilation in Ender's Game, and then they're like, but we have this magic thing that lets us communicate because otherwise we can't tell the story that we want. That sticks out more, you know? And so I think that that's kind of why the Ansible is a little bit more of a, but both of them in theory would use, well, I believe the Ansible actually does mention that it uses like entangled particles or something like that.
Oh yeah, it's space magic because they could not have invented it, right? They stole it from the buggers.
But yeah, no, I think that from, there, I believe if I remember correctly, in that book, they do mention that like there is some type of like entanglement there, you know, so they get closer to like that side. Whereas in Star Trek, they're like subspace. It's like, what's up? Subspace, you know?
It's not what the story's about.
Yeah. So the answer is don't think of subspace. God, move on.
Well, I will leave you with this one last thing to wrap up, to connect these two sci-fi things. You know where they did go from the Ender's Game version to the Star Trek version and it screwed everything up? Star Wars. The inciting moment in Star Wars is Princess Leia putting the message on R2-D2 and then sending R2-D2 into space. And then in like 7, 8, 9, they just talk to each other over the radio instantly while at hyperspace. And it's like, so none of that mattered. Was this like a horror movie where like her cell phone battery was dead? So like she lives in a world with cell phone batteries or cell phones, but she was stuck someplace that had no coverage. Like you have to remove magic communication when it's not convenient, but then you remember you have it when you don't want the story to be about communication delays.
Yeah, and actually, I believe that type of technology and communication is really more your area of expertise, which reminds me of another thing I wanted to ask you.